Hi all, hope you had a good day. So today we are going to look at some things before we dig deeper into ML. So we are going to have a refresher of the basics of Python, how you can load CSV files, how you can reprocess these data from CSV file, and yeah, so basically data exploration as a whole. So we have this data that I've uploaded to my GitHub repository. So what we will be doing is we will be loading this data directly from GitHub, so you don't have to download it. But for you to load this data, you need to ensure that your PC is connected to the internet. There is this link that I'm going to share in the chat section, and then you can open that link and get access to the data that we are going to use for this class. Okay, another thing you need to do is you need to create your new IPYNB file. So that is your Jupyter notebook. So go ahead and launch your Anaconda Jupyter notebooks and then we can begin. Okay, so Naomi, I'll share that on WhatsApp too. Okay, so just give me a minute. I'm going to share that. So there you go. You should have the link. So what I'm going to do is I'm going to create my new Jupyter notebook. And I'm going to name this notebook my refresher EDA. Okay. So that's the name of the notebook. So I'm using dark mode, so hope you are all good with that. And I hope you can all see my code. So when dealing with data, the first thing you always need to do is you need to import libraries that you can use to process your data. And these libraries include pandas, which allows you to load your data. We have matplotlib for data visualization, and we have NumPy for scientific computations. So we will start by importing libraries that we need. So I'll add a comment here. So import libraries. So I'll have pandas come in first. I'll have NumPy come in second, matplotlib, then Seaborn. So those are the libraries we basically need for now. Then I'm going to run that code cell. So as we've mentioned, pandas allows us to manipulate our data. NumPy is for scientific computation. So if you need to calculate things like the mean, average, or some other stuff, because NumPy is at least fast when it comes to computations. So yeah, this code cell is running. Let's wait for it. Then we have matplotlib, which is for data visualization, and we have also Seaborn, which is for data visualization. So those are the the four libraries that we are going to use in this class, basically. So as that is running, we need to again import our data. So we are going to have our df being equal to pd.read underscore CSV. Then this is how we read online files. So I'll just paste in here the link that we had. So the link that I've shared with you from GitHub. And also remember, I mentioned that you need to be connected to the internet for these to work. Then after importing the data, what we are going to do is we can check the top 5 rows of our data. So these are the basic procedures that we usually follow. And we can do that by typing in df.head. Okay. So it's taking more time to run, but once it starts, then everything should be okay. So can you all see my notebook here? Like the codes that I'm typing. Hope you can see them. So here we have the data importation part. Then we've checked the top 5 rows of our data. So that's basically the first step. So once you've imported your data and you've checked the top 5 rows, the next thing you need to do is you need to explore your data and understand what kind of data am I dealing with. So for example, here you can see we have customer ID. So we can convert the customer ID to maybe be the index column. Yes, Belinda,
Yes, Joseph, sorry to could you slow down a bit? Sorry.
it's okay. So I'll give you around 3 minutes to work on this and then we can proceed. I hope you are all good now. We can proceed. Yeah, so this is what I was talking of. So the first thing you need to do is explore your data. So for example, here we have the customer ID column. So is the customer ID column in what we are doing? We have age, gender, the item purchased, the category of item, purchase amount, location, size, color, season, review rating, subscription status, payment method, shipping type, discount applied, promo code, previous purchase, preferred payment method, and frequency of purchases. So those are the things, those are the variables we have in these data. The next thing we usually do is we check the data info. And here we will run df.info and we will get the data description. So using df.info, we get the data description. So we will start from up here. You can see we have 3,900 observations from these data. And these are from 0 to 3,899. We have a total of 19 columns in here. And we can see what kind of data type is in each column. So for example, the customer ID is in 64, the age column is in 64, gender is an object, so meaning it's a string, item purchased is an object, category is an object, price in amount, purchase amount is an integer, location an object, size an object, color, season object, review rating a number, which is a float. Then we have these other ones: subscription status, payment method, shipping type, discount applied, and promo code being objects. We have previous purchases being an integer. So previous purchases, I guess that's the number of previous purchases that might have been made by these customer. Then preferred payment method and frequency of purchases, which are both objects. So after knowing that, what should we check next? So the next thing we usually do is we check if our data has duplicates. Okay. So these are some of the things we usually check here at first. So we will have df dot duplicated dot sum. That's how we check if our data has duplicates. And you can see that our data has no duplicates. What if the data had duplicates? Okay, so what will you do? So you could drop the duplicates using df.drop duplicates, then in place being equal to true. That's basically how you drop the duplicates. So you don't have to type this. So I'll share this notebook with you guys. And then from there, you can copy these notes parts. So the most important part for us now is the code part. So we've checked for duplicates and we've seen in our data, we have no duplicates. After duplicates, check, what do we check next? So we check if our data has missing values. So we have two methods of doing this. So we can use isNull or we can use isNA. So they both work the same way. So we type in df.isNull.sum. So these will tell us if our data has duplicate, has missing values or. So we can see that this data is clean and it has no missing values. Any questions up to where we are now? I believe everyone should be okay. Okay, let's continue. So after checking the data quality, so the next thing we usually go to is the exploratory data analysis. And for exploratory data analysis, we can start with the numeric columns. Okay. So for numeric columns, which are our numeric columns in the data. So from the data.info part, we have the age of the customer. So we can ignore the customer ID since this is like This is like an index column, so we can ignore that. We have age, which is an integer, purchase amount, an integer review rating, and previous movies purchase. Okay, so there is an easy way of extracting numeric columns. So I'm going to create a list with the numeric columns. So I'm going to say num calls should be equals to df.select underscore d types. Then we will have include np.number dot columns. So this will include all columns that are numeric. Then I can go ahead and print them out. Okay, so these are columns in our data that are numeric. So we have customer ID, customer age, purchase amount in USD, review rating, and previous purchase. So after we've extracted our numeric columns, so what should we do next? So the next thing we can do is we can plot the distribution of these numeric columns. So for example, we can start with the age column. And what I'm going to do here is I'm going to plot a histogram for the age column. Yes, Dennis.
Slow down, slow down. You're too fast.
Okay, sorry for that.
Yes.
Okay, so one more minute and then we can proceed. Okay, so I guess we can proceed. So here for the histogram, what we will do is we will create maybe a function that can allow us to plot the distribution of numeric columns. Okay, so not all numeric columns will have a plot that will be good looking, but we will try and see how we can make them better. So this will be our initial plot, and then we are going to advance our function. So we are going to have def plot numeric. Then here we take our column. So that is the column name. And then from there, we are going to have our SNS dot displot. Then we plot the distribution for that column. And then we add a title. So we will have plt.title. Then this is the f printing method. And for the f printing method, we usually type in the text, we open square brackets and type in something that should be in here. Then we can have plt.show. So this is a small function that will allow us to do our plots with ease. And we are going to test it with the age column. So let's do that. So I'm going to give you more time to copy these. And as you are doing that, I'm going to plot the distribution of the age column. So what I'm going to do is I'm just going to type plot underscore numeric, then we pass in the age column. So just a single line of code. And we can get our plot. Just a minute. I correct this and then you can copy the code. Yeah, so 3 minutes you copy the code and then we can proceed. Okay, so I guess you have your function created, so we can go ahead and visualize our data. So this is the plot for the distribution of age. So we just type in plot underscore numeric, then we pass in our age column. So you can see that for each age, so for example, for each age group, we most likely have a uniform distribution because the count for each age group is almost same. Yeah, so I think that should be a good sign. And that's our first plot for a numeric column. Then another column we are going to visualize is the purchase amount in USD. So we're going to type in plot underscore numeric, and then we are going to paste in that column. So for purchase amount in USD, we can see it ranges from the lowest being 20 and the highest being 100. And the count is also same in almost all cases, as you can see there. Then another numeric column we have here is the review rating. So we are going to have plot numeric, and then we are going to have the plot for the review rating column. And for the review rating column, we have 2.5 up to 5.0. So those are our data points there. Okay, so I'll leave the further exploration to you guys. So in terms of like explaining what you see in these plots, so I'll leave that for you to work on. So for me, I'm just showing you how you can leverage Python to plot this thing before we can shift our focus back to machine learning. Okay, so let's proceed. So the last plot that we are going to have for plot numeric is the previous purchases column. And for the previous purchases column, we have 0 to 50. So that's what we have. Yeah, so those are our distribution plot for numeric columns. Any questions on what we've done here? And maybe the ease of using a function as compared to us typing this code as a whole. Any questions on what we've done so far? Okay, if you have no questions, then we will work on the final thing for today, and that is plotting categorical features. So for categorical columns, what we will do is we will borrow this code that we have here and customize it for categorical columns. So here what I'll do is I'll change this from num columns to be cat columns. So meaning categorical columns, which are the object. And here what I'll include is I'll include objects. Okay. So that's how you include categorical columns, and then we can run that. So here you can see, for example, we have the gender, the number of items purchased, the category, location, size, and color. So in most cases, what we usually plot here for the distribution of categorical columns is a count plot. So that is what we usually use in most cases. And in this case, that's still the same thing we are going to use. So I'm going to create a function to plot the count of categorical columns. So here we are going to have def plot categorical, and then we are going to have sns.setStyle. So we set our style to be a white grid. Then we can have sns.countPlot. Then we add our title. We rotate our X ticks in cases where the labels are not that clearly visible, and then we show our plot. So what I'm going to do is I'm going to visualize only two columns here, and then I'll leave the rest for you to work on. And what I'm going to visualize is maybe the location and the gender. So we want to see the distribution of gender and the different locations that we have in these data. So we are going to have plot categorical, and then what I'll do is I'll pass in the gender column. Okay, so could not convert string to float. Let's see. So we have to customize our column, our data. So let me do one count plot up here. So our data should be equal to df, then x should be equal to, let's say, gender. So I guess that's what I'm supposed to use. So here I'll change this. So I'll say data should be equal to df. Then I'm going to add a comma. Our x should be equal to the column that we are plotting. So that's our customized function. And then I can run this. Yeah, so I'll give you 4 minutes to work on this, and then we can proceed. And maybe we can summarize what we've done for today. So I guess you should be done. So here, if we check the categorical plot for gender, we can see we have males and female, and males are the majority. So instead of a count plot, you can go ahead and plot something different, like a pie chart. So yeah, you can go ahead and try them out. Let's proceed. So the other plot I promised to show you was the location plot, and then you can do the rest. So we have plot categorical, then we are going to plot the location. So if we plot location, you can see we have different locations in here. So I guess the best thing you could do here is you could output maybe a count. So you could output a value count for each that you have here. So for each location that you have here. So let me change location to something like category, which I think should have fewer values that we can see better. So for this store, we can see they have clothing, footwear, outerwear, and accessories. So those are some of the categories of products that we have in this store. Yeah, and basically that brings us to the end of today's class. So what I want you to focus on mostly today is on some of the few aspects that we've discussed, and that's what we will be discussing this week. So just the basic EDA. So reminding ourselves some of the things we can do using Python to help us understand our data better. Yeah, I see Jesse has a question and Belinda. So Jesse, you can go first.
Uh, I have a question of that plot on gender.
Yeah,
Is that part of X6?
yeah.
What does that rotation 90 mean?
So it
On,
rotates these labels that we have here by 90 degrees. So for example, if I change this to 45 degrees and I run my code again, you can see the labels for each category rotates by a certain angle. So that's the use of these X sticks rotation path.
my second question is,
Yeah.
can we work all this on the Google Colab, or do we are just restricted to the Jupyter Notebook?
No, you can use any tool you are comfortable with. So you are not restricted to any tool you want
Okay.
because they are all Jupyter notebooks and the structure is the same. Yeah. So no restrictions. Yes, Belinda.
Hi Joseph, hi everyone. So my question is, can you just show us how to plot, let me say like gender against number of items purchased, where there are different data types, like the categorical and
Okay.
sorry, the different data types, the numerical and the yes, the other type. Sorry, that skipped my mind.
So for that, you need to add a hue. So plot, for example, I can plot the distribution of price for each gender. So what we usually do is we add a hue. So we can have sns dot hist plot. Okay. Then this is markdown. Just a minute. I'm going to show you that. So we can have sns.histplot. Then I select the let's say age column. And I guess if we have a hue part, we can say our hue should be equal to gender. So yeah, let's try that and see if that works. Let me shift this to here. Then I specify my X to be equal to gender. Then hue. So what distinguishes between male and female is the hue part here. So I can type age. So you can see the distribution for age for both male and females. So you can ignore the stack part and you can have something like this. So if you are plotting like the amount purchased, so let's say maybe the review rating. So if you want this review rating for each gender, the distribution of review rating for each gender, so you just have to add the hue. So this is the only thing you add. And then it means you have to customize your function so that you specify your data and your X. So you are not just specifying the column only now, you are specifying different things. So data and the column that you want to plot. Yeah, so that's it. Hope that
Thank you.
answers your question.
Yes, it does. Thank you. I was just wondering if maybe, but I think I can do that as a test, to just extract only female or maybe male
Yeah.
and just have only, yeah.
Okay, you can do that, I guess. So you need to add filters here. So if you are to extract only a single categorical type, so here I extract only for males. So I add a filter for that. But I guess you can, I'll leave that code there. The first one that we had, just a minute. And then I'll add the second one where I filter route females so that you can go ahead and try it out once I share this notebook with you. Yeah, I saw someone else had a question.
Thank you.
Welcome. Yeah, Michael.
Okay, so my question is just on the output that I'm seeing on your end.
Yeah.
I'm seeing I typed the same code, but I'm not having the different colors you're having on your output. Is it part
So
of the settings or is Jupyter?
so
Because I'm using Google Column.
it might be what I'm using. But if you set white grid, then I guess we should have similar outputs. But I guess the most important thing is you are getting the plots correct, right?
Yes, I am.
Okay, so the colors might be due to the styling, so you can confirm that.
Okay.
Okay. Yeah. Anyone else with a question? Yes, Jesse, I'm available for consultations. So you can just reach out to me anytime you need help. So I'll stop the class recording there for today.